Hi, Assalamualaikum and good evening. I'm Muhammad Irshad bin Muhammad Aziz from DAM 5D, number metric 24 DAM 18F 1081. Here with my fellow group member which is Ahmad Nazif bin Abdul Majid, 24 DAM 18F 1094 and Muhammad Danish Hanafi bin Muhammad Anwar, 24 DAM 18F 1096. We are going to present a craft structure and system to chapter 11 about information system. Okay, so the first one is Air Traffic Control System Description. The overview. The ATC system operates through an air traffic control ATC data link application hosted in the CPIOM D1. So what is CPIOM? CPIOM is stand for Coprocessor Input Output Module. It is a variant that provides a combination of compute resources, input and output ports for distributed data pre-processing or tightly coupled control loops. The next slide is this application collects or exchange data with number one, aircraft system, aircraft parameters. Second one, the printer one. The third one, the ATC centers through the avionic communication router ACR hosted in CPIOM D3 and communication means. Number four, flight crew through various human machine interface, also known as HMIS. So the next slide we are going to talk about the interface that are involved. The first one we can see captain and first officer ATC message, push button and loudspeaker to indicate the arrival of an ATC. So okay. The next one, captain first officer keyboard and cursor control unit, KCCU. Basically it is to type, file or manage message. And the last one, an ATC COM page shown on the MFD1 and 2. This page gives the ATC system information. Later I will show you how it works. ATC COM page shown by selecting the ATC COM page on the MFD with the cursor or with the ATC COM key available on the KCCU. An ATC mailbox shown on the SD. The mailbox shows the ATC system message exchange between the flight crew and the ATC centers. KCCU include a mailbox key to switch the cursor from the MFD to ATC mailbox and vice versa. So after all the things that I talk about, so right now we can see ATC system overview. The left hand side, there is flight crew, and then we can see captain and first officer keyboard and cursor control unit. This is what we call KCCU. And in the KCCU, we can see there is mailbox and ATC COM push button. We can push this mailbox if we want to see what ATC message to flight crew. And we can push the button ATC COM. There is multi-function display MFD1 and 2 at the ATC COM page. And this is from there we can see this is all ATC system HMI that I talk about human machine interface. And then we can see aircraft system ADIRS, AESS, FMS. So ADIRS is a data initial reference system, AESS aircraft environment surveillance system, and FMS flight management system. This is all going to the CPIOM D1 air traffic control data link application, and from that D1 going to the D3 SCR, which is avionic communication router, and then CPIOM D1 will go to the printer 1, and then CPIOM D3 will go into the HFDR, VDR or SATCOM. And then we have here air traffic control center.
Okay, next is ATC system function. The ATC system, through its ATC data link application, improve exchange between the ATC centers and the aircraft. This application includes 6 functions, which are the controller pilot data link communication (CPDLC), the automatic terminal information service (ATIS), the Automatic Dependent Surveillance ADS, the Departure Clearance CLRNC, the Air Traffic Service Facilities Notification AFN, the Oceanic Clearance OC. Okay, next is the function of the 6 components. CPDLC. The CPDLC function allows a dialogue between the flight crew and the ATC by managing uplink and downlink message, a predefined set of message, and free text can also be sent or received from the pilot or the controller. ATIS. The ATIS function lets the flight crew request and obtain information about terminus area condition via HF, VHF, and SATCOM systems such as runway, approach procedure, and meteorological parameters. Next is ADS. The ADS function automatically generates surveillance data reports for the transmissions to the ATC centers. Depending on the type of the ATC center needs, the ADC reports are sent when at periodic time intervals, only when asked for, and whenever a specified event occurs such as speed, position, altitude change, and waypoint change. Next is Departure Clearance. The Departure Clearance function lets the flight crew request and obtains departure clearance. AFN. The AFN function is used for data link connection between the aircraft and the ATC centers. This function sends information concerning the aircraft like its aircraft tail numbers and others. The last one is OC. The OC function lets the flight crew request and obtains oceanic clearance. This is the ATC function from CPDLC to OC. Next is ATC system architecture. The ATC data link application interface with various aircraft systems, which are the ACR, which let the ATC data link application use the worldwide air or ground data communication through several communication means: high frequency data radio HFDR, VHF data radio VDR, and SATCOM, and the Aircraft Communicating and Reporting System ACARS network. The Aircraft Environment Surveillance Unit AESU, which give the ATC data link application with the Traffic and Collision Alert Avoidance System TCAS status TCAS, whether it's operational or not. Note, the TCAS status is used by the ATC controllers on ground to determine the clearance for flight level accordingly. The clock which gives the ATC data link application with the date and time. Air Data and Inertial Reference Unit ADIRU, which provide the ATC data link application with the Global Positioning System GPS, date and time, and air data and inertial reference parameters such as speed, position, heading, and altitude. Flight Management Computers FMC, which use the ATC data link application to request and receive route clearance and report from the ATC centers. The Cockpit Voice Recorder CVR, which record ATC message alongside voice recording and give the ATC data link application with the CVR status, such as recording failure or ready to record. The Onboard Maintenance System OMS, which support the data loading, the configuration, and the centralized maintenance of the ATC system. The Flight Warning System FWS, which manage two visual ATC message annunciators and an aural Attention, get the ringtones on the loudspeaker through the audio management units, AMU. NATC switch, NATC reset switch lets the crew reset manually the ATC data link application. The ATC system is connected to the printer 1, which used to print ATC message and ATIS report. So this is the ATC system architecture.
Network server system and onboard information system description. The onboard information system that is part hosted in the avionic domains. It supplies 4 things. The first is an onboard or ground communication capability between the aircraft and the airline operational control centers. The second is tools to support maintenance operations dedicated to the avionic world and to the avionics domain. The third is electronic documentation related to flight maintenance and cabin operations. And the last is servicing dedicated to refueling operation. The avionics domain is accessible from the cockpit, from the cabin, and from additional areas on the aircraft through various human-machine interfaces, HMIs, which are the onboard maintenance terminal, OMT, the captain and first officer onboard information terminals, OITs, the portable multipurpose access terminal, PMAT, the main and upper deck multipurpose, FAPs, printer 1 that is connected to avionics domain only for data or reports retrieval, and the printer 2 that is connected to flight OPS domain only that is used by the flight crew and the maintenance personnel. In normal configuration, the onboard maintenance terminal is supplied with 115 VAC from AC bus 3 and AC emergency bus. The onboard information terminals is supplied with 115 VAC from AC bus 4. The onboard information terminals first officer is supplied with 115 VAC from AC essential bus and AC emergency bus. And the printer 1 is supplied with 115 VAC from AC bus 1. Control. The network server system NSS controls are as follows. The first is 2 NSS reset CBs on the 1222 VM for avionics and flight operations domain. And the second is 2 onboard information terminal site SWs located on the 1511 VU for the captain and 1512 VU for the first officer with 2 positions NSS avionics and FLT OPS. The third is 2 OIT brightness potentiometers located on the 1313 VU for the captain and 1314 VU for the first officer. And the fourth is a NSS master SW on the 1211 VM panel. In case of smoke detection, this SW activates a hard shutdown of NSS line replaceable units, which is LRUs, installed in the upper avionics bay. A GND connection PB on the maintenance panel 1255 VM to connect the PMAT to the NSS. And for the components, the captain and first officer OIT with their keyboard and additional control device ACD are installed at each side of the cockpit. The OMT is installed at each rear part of the cockpit. The MP FAPs are located in the main and upper deck. The PMAT network plugs are located as follows. First is cockpit OMT rack at 1543 VU, main avionics bay 1913 VU, upper avionics bay near the interphone plug 1914 VU, AFT avionics bay near the interphone plug, nose landing gear, body landing gear bay in refuel panel near the interphone plug, FWD lower deck cargo compartment in service panel RH, AFT LDCC in Service Panel RH. The printer 1 located in the center pedestal. The printer 2 located in Captain's Side Console 1501 VU. And note, there is no power plug in the APU bay and OMT rack. Note that the PM80 works on battery. These plugs are used to connect the PM80 in order to get only access to avionics domain maintenance applications. Thank you for listening.